All right, so let's have a look at our index laws and our solving our exponential equations. We have to know these boys. Okay, so if we've got the same base, we're multiplying, we add the indices. If we're dividing, we subtract the indices. Okay, so it's just a non-negotiable. We have to know these rules. To solve tech-free, the idea would be to get the bases the same wherever you can. All right, so if we have a look at these first couple, 2 to the x is the same as 2, sorry about that, 2 to the x is the same as 2 to the 5, and because the base is the same, it means the powers are the same. It's called equating. Okay, and that's probably the simplest way. If we divide both sides by 2 here, I get 3 to the x is equal to 81, which means 3 to the x is equal to 3 to the 4. Again, the bases are the same, so the powers must be the same. Okay, 2 to the 1 minus x is equal to, or 16 is 2 to the 4. So it's about writing every number in the slowest base. Bases are the same, so 1 minus x has to equal 4 because the powers have to be the same. So let's solve that, which means x is equal to negative 3. Okay, here's what I would consider the nice ones. D and E, they're as close as we get to having to use solving quadratics, I guess, tech-free. So let's have a look a little bit about it first. Let's rearrange everything. Let's get 4 to the power of x minus 12 times 2 to the power of x plus 32 equal to 0. All right, so the key here is to realise and see that this is actually a quadratic. If I do a little substitution here, if I pretend that u is equal to 2 to the x, well, that means u squared is 2 to the x all squared, which is equal to 2 to the 2x, isn't it? So let's keep that in mind. Let's rewrite 4 as 2 squared minus 12 times 2x plus 32, which means I get 2 to the 2x minus 12 times 2 to the x plus 32 is equal to 0. So these expressions here, they're my u and u squared that I referenced. So I can actually just rewrite that as u squared minus 12u minus 32 equal to 0. Now if I factorise that, 8 and 4 seems like it should be a good thing. Hang on, I've changed signs, that's a plus. Just didn't read that properly. So 8 fours are 32, so minus 8 minus 4. So I get u minus 8, u minus 4 is equal to 0, which means u is equal to 8 or 4. Now u is something that I created, and u is in fact 2x. So I can now write that 2 to the x is equal to 8, and 2 to the x is equal to 4. Get the bases the same. It's equal to 2 cubed, 2 to the x is equal to 2 squared, which means x is actually equal to 3 or 2. Okay, so the key is there, it's just seeing that whilst 4 and 2 aren't the same base, we can make them the same base, and the only thing that's different is the power. Let's do something similar for E. So what have we got? Let's get all on the one side. So we've got 9 to the x minus 28 times 3 to the x minus 1 plus 3 is equal to 0. So let's have a look. 3 squared to the x minus 28 times 3 to the x times 3 to the minus 1 plus 3 is equal to 0. So let's write that as 3 to the 2x minus 28 on 3 times 3 to the x plus 3 is equal to 0. So you can see we've got that 3 to the 2x, 3 to the x thing, so that's my u squared. I've got a 28 on 3 there, which is a bit messy. So what if I just multiply everything by 3 first? That gives me 3 times 3 to the 2x minus 28 times 3 to the x plus 9. Just get rid of that fraction. So now, again, if u is equal to 3 to the x, u squared is equal to 3 to the 2x. So we can turn that into a 3u squared minus 28u plus 9 equal to 0. Well, let's hope we can factorise this. 3u cross with, so it's either 9 and 1 or 3 and 3. So 3 9s are 27, plus 1 is 28. So I reckon that's the way. Make them both negative. 3u times, so if we do down our 3u times 9 is equal to 27u. U times negative 1 is minus u, negative 28u. Bingo. So we get 3u minus 1, u minus 9 equal to 0. So we get u is equal to 1/3, or u is equal to 9. U is something we introduced. It's equal to 3x. We come back up here. So I get 3 to the x equals 3 to the minus 1. 3 to the x equals 3 squared. So x equals negative 1. X equals 2. So as I was saying before, I reckon that's as close as we need, that's as close as we get to needing to be able to factorise in a tech-free exam. Just seeing it's in that exponential equation, all right? Have a go at that. Practice some of these from 5C, and yeah, we'll pick it up in class.